Good afternoon, everyone. So I hope everyone is having a great time at the summit by meeting many talented folks and interacting with fellow OpenStack members. So I'm here to talk about how Yahoo plans to maximize resource consumption and why it is important to understand resource utilization and allocate your resources based on that. So just to give a brief overview that Yahoo operates at an immensely huge scale, and our problems are completely different and are like operating at such a huge scale can lead to many interesting problems, and you can be the first one to encounter them and face them. So we'll cover a few of the problems that we encountered and how we made sure that we maximize the resource consumption. So Balaji was not able to make to the summit, so I'll be covering the talk. So so who am I? So I work for Yahoo. I work for the OpenStack team at Yahoo. I am one of the Magnum core contributor. Magnum is container as a service. I'm leading efforts for cross-project quota library, which is known as Delimiter. So what to expect in this talk? So why thinking about resource consumption utilization is important? Then does the current OpenStack scheduling or resource allocation mechanism takes into consideration resource utilization or not? What strategies can we use in OpenStack to increase utilization of resources? And what Yahoo has used and plans to use in future? Then future enhancements. So what are resources? Before delving into deep, what resources are we talking about? So any distributed system or systems is composed of preliminary these 3 or 4 different resources like CPU, memory, disk. We can consider network and power. So by CPU means how much CPU is used at a particular instance and how much RAM is consumed, how much disk is consumed, and how much is available based on which we will schedule the resources. So there have been studies done previously by Google, Twitter, and even Yahoo, and there have been publications done in the computer science community. And there is a trend, if you can see the graph on the left, there was a study done in 2014 that less than 20% of CPU is utilized at a particular instance whenever in big clouds like Twitter or Google. Even if you see on the right side in Google, the CPU utilization is less than 20%. So what this shows us is not all of the resources are completely utilized. So even though we have spent tons and tons of millions to buy our hardware, are we actually consuming all the resources that we have got? So low utilization in large scale clouds, less than 20% CPU use. So despite sharing of resources with automated management systems, we see less than 20% utilization. This utilization is even less than 6 to 5, is close to 6 to 15% for other companies which are operating at that scale. So server, and one important thing to note here is server accounts to 75% of the total cost of ownership. So it amounts to huge amount of money to buy servers. But if they are not utilized optimally, it doesn't make sense that even though we have bought such a costly thing, we are not utilizing it to an optimal level. So expectation, what everyone expects is efficient use of resources for optimal consumption and good performance. So we expect a good performance. At the same time, we expect optimal consumption. So scaling through resource efficiency. So few questions when someone is designing, we need to ask ourselves that, are we using our current resources efficiently? As we saw in the previous graph that less than 20% of resources are used. So are we using our resources efficiently? Are we building right systems to begin with? First of all, as a designer, as an architect, we need to ask these questions. So first of all, we can analyze resource consumption and then analyze the resource allocation mechanisms. So how the resources are allocated and see are they good enough, or they take into consideration the utilization matrix. If not, how can we design for maximum utilization? So So before delving more into what we did, I'll just give a brief overview of how resource allocation happens in OpenStack right now. So OpenStack scheduler is the main component which will do resource allocation for an instance. By resources, I mean the CPU, disk, RAM. So first of all, whenever user boots instance, the API gets the request and it goes to conductor. And if you see in the third step, the conductor passes on the request to scheduler, and scheduler has a set of filters and weighers based of which it will decide like, okay, I have X amount of RAM free, I have Y amount of CPU, and I have Z amount of disk, and all of my hosts are in these aggregates, these availability zones. Based on all the permutation and combination, scheduler will pick up one node from which the instance will consume the resources. Okay, and then once the scheduling has been done, the request will be request will be passed on to the conductor, and the conductor will pass the information to the compute, and the compute will be the one which will be actually spawning the instance. So filters and weights. So I spoke about filters and weights. So filters and weights, this is a standard slide you can see in any of the OpenStack documentation. So what happens in filters and weights is like you have 6 set of hosts, let's say, and then in your deployment, and then you applied a set of filters to them, and out of them 4 were chosen, and then weighing is just like, out of these 4, which one is the most suitable one. So at the end of the day, out of these 5, 3, 1, 2 on the right, I picked 1. And since the scheduler host subset size is 1, finally, let's say host 3 was chosen, and you boot an instance there. So analysis. So what analysis can we make from this is like the filter scheduler is an overall solution in OpenStack to allocate resources, at least compute resources. So the question to ask is, does it provide strategies to take into consideration resource utilization? If not, then what can we do for that? Then a primary factor of weighing is memory. So this is something tricky because most of the workloads or most of the resources are more CPU intensive rather than being memory intensive. So even if your host or your hypervisor has like 200 MB or 200 GB of free memory, but your CPU on that hypervisor is highly overloaded, even if you spawn an instance or launch your app on that particular host, you're not able to get the performance that you want to expect. So weighing based off memory is not a good thing. So it is important to gather and combine both static properties and dynamic usage strategies to generate the weight. So both the static properties, that is whatever information I have in my cloud, as well as whatever is actually going on. Because if you consider the case of Yahoo, the traffic is not consistent. You might get, like if you have a baseball game or if you have a football game, the traffic might spike up, and then there might be instances where the traffic might be consistent. So you need to be able to design your system, architect your system in a way that it takes into consideration both static as well as dynamic properties, that is what is going on, and design accordingly. So strategies to improve resource consumption. So over-provisioning of resources. So by over-provisioning, it's like think of the worst, and worst will never happen. So you provision accordingly, you provision well more resources beforehand, and then you think of the worst, and the worst will never happen. So not always useful, might even lead to, might not always lead to optimal consumption, might sometimes lead to wastage of resources. So scheduling based off utilization. So till now the OpenStack scheduler does not take into consideration all the resources. So how can we take into consideration the utilization of resources and do the scheduling? So report utilization data, feedback mechanism that there is huge traffic, how things are, whether it is consistent traffic or huge traffic or low traffic, resource consumption based off utilization and usage patterns. So utilization based scheduling, so resource tracking. So the compute will return the list of the statistics about how the resources are consumed, and like what is my RAM usage at this moment, what is my CPU usage, what is my disk usage, and it will dump the information to the DB, So if you can see that resource claiming, all the resource tracker is a component that runs inside compute, which gathers all the information from the hypervisor and it reports to the NoaDB. So monitor plugins. So this is something that we have contributed, that I have contributed to the community. I have proposed a new spec to introduce disk and monitor plugin, memory plugins. So this, the CPU plugin, which is shown in red, was already there. What it results, or what it represents, or what it feedbacks is the CPU idle percent, IO wait percent, the CPU kernel percent, what is the utilization of CPU at a particular instance. And what I have contributed, what I have proposed is how much RAM is utilized at this moment, how much RAM is free, how much it is used. Similarly, we can think of how much disk is used, how much disk is free. So based on this, we come up with this architecture. So what this does is utilization aware filters and weights we have that the scheduler works on. And we have the resource tracker and the resource monitor plugin. So these two entities, that is memory and disk, which are in blue, highlighted in blue, these are what we have contributed. So these plugins will get the actual utilization of memory and disk and report to compute, and compute will dump the information in the DB. So yeah, so this is the utilization at Yahoo after we used all the information mentioned here. So if you can see in November or October timeframe, it was really low, but if we use the strategies, the consumption or the utilization has gone up. So looking ahead, so what do we want to do going ahead? Making decisions based off historical utilization data. That is not only take into consideration what is the actual utilization, but what happened 5 months before. How do we plan accordingly? How do we plan our inventory management accordingly? How do we schedule resources based on historical data? But it can also be useful when you want to trigger instance migration. So let's say the fault or network partitioning is something that happens every day in and day out. So how do you make sure you take into consideration the faults that happens? If you migrate an instance from one host to another, how do you make sure that you take into consideration the utilization at that moment? So all these factors needs to be considered when designing all these systems. So we have this in our plans, and we would like to work on this. So thank you. Thanks a lot. So questions and answers.